In copper plating, a current of 0.5 ampere is allowed for a cathode area of 100 centimeters square. And then, if this current is maintained constant for 100 minutes, calculate the thickness of the copper deposited. The electrochemical equivalent of the copper is given as this, and density of copper is also given as this. So let's bring out these parameters for easy calculation quickly. So we have 0.5, which is the current. So 0.5, I would like to write this in standard form for easy calculation. So this is going to be something like this. And then we have the area of the cathode, which is A equal to 100. So 100 in standard form is going to be 10 raised to the power of 2. If this current is maintained for 100 minutes, 100 minutes, so the time t is 100 minutes, we need to change this to seconds, and to do that, we multiply by this. So we should be having 6,000, and then in standard form, it's going to be this times 10 to the power of 3 in standard form, okay? And then we have, what again do we have? The electrochemical equivalent, which is represented by this letter Z, which is 0.00033. So I'm going to write this in standard form as well, which is going to be this times 10 to the power of minus 4, right? And then we have the density of copper. So the density of copper is given as this. So let's just take note of that. 10 to the power of 4. So density is given as 10 to the power of 4. In this question, firstly, we are going to calculate the mass of the copper which is deposited. And then after that, we are going to find the volume of the copper before we can find the thickness of the copper. So to find the mass of the copper, so we're going to apply this equation according to Faraday's first law of electrolysis, M equal to this times this. Yes, so here, this is the electrochemical equivalent, this is the current, and this is the time taken. So we are going to substitute this value into this now. Our mass of the copper is going to be this now. So we are having 3.3 times the current, which is 5.0 times the time. The time now is given as this 6.0. Remember, everything is in standard form, so in base 10. So we have that of the electrochemical equivalence. The power is -4 here. So having -4, -4, that is times 10 to the power of -4. Then the next one is -1, and then we are having +3 here. So we can write everything as this +3. So 3.3 here times 5 times 6. 5 times 6 is 30, and 30 times 3.3, we should be having 99. So so this is 30 times 10. The base is 10. So -4 minus 1 is -5 plus 3. So we should be having -2 here. Okay, so 3.3 times 30 is 99. So we're having something like this times 10 to the power of -2. So this is the mass. So in proper standard form, so we should be having 9.9 times 10 to the power of -1. So this is going to be the mass of the substance that is deposited. That is the mass of the copper. Now, after finding the mass of the copper, we need to find the volume before we can find the thickness of the copper. And then to find the volume, we are going to make use of this equation. Volume is given as mass of a substance over its density, right? Something like this. So now our volume V, we have found the mass to be 9.9 times 10 to the power of -1. Then the density is given as, density of copper is this, 10 raised to the power of 4, right? So V, volume of the copper, is given as this now, 9.9. So they have common base. So we're going to have 9.9 times 10 raised to the power of -1. And this plus 4 goes up, is going to change to -4. So the volume of the copper now is going to be 9.9 times 10 raised to the power of -5 in centimeter cube, right? Okay, now we can now find the thickness of the copper. So thickness of our copper, of the copper. To find the thickness of the copper, we're going to apply this equation, which is going to be the volume divided by the area. That is volume over area. So this is going to give us thickness of the copper, and then we're going to have 9.9 times 10 to the power of minus 5 over area. The area is given to us somewhere here, which is this 10 to the power of 2. So let's finish it up here. So the thickness is now going to be 9.9. So this is going to be 9.9 times 10 to the power of minus 5. And then here we have common base 10 and 10. So this plus 2 will go up. We change to minus 2. So we are going to have 9.9 times 10 to the power of minus 7. So this is the thickness of the copper in centimeter. That is going to be the unit. So this is how to solve a problem like this in electrolysis. Thank you for taking your time to watch this video. Please do like it, share it, and endeavor to follow my page if you are not a follower. For more updates, goodbye.